Here we're asked to graph this quadratic here that is in standard form, and so I'm going to try and get 5 kind of reference points here to guide my graph, starting with the vertex. And to do that, I'm going to use what we call the axis of symmetry, negative b over 2a, part of our quadratic formula. And I'm going to plug in some values here, so negative 16 is my b value, and 2 is my a value. So that becomes 4, which is what we call the axis of symmetry, but also is just the x value of our vertex. So now, to find the y value, I'm just going to plug that in. So y equals 2 times 4 squared minus 16 times 4 plus 33. So I got 2 times 16 minus 64. No, is that right? That's not right. 16 times 4, 64. Plus 33. 32 minus 64 plus 33. It's going to be nice because it's now just negative 32 plus 33, which is just 1. So our first point here in our vertex is just going to be 4. So now that we have our first point, I'm going to find 2 points to the right of it just because I know that quadratics are symmetrical. So I'm going to plug in 5, then I'll plug in 6 to see what we get here. So 5 squared minus 16 times 5 plus 33, and then y equals 2 times 6 squared minus 16 plus 33. And so I'm going to fast forward this, but we're going to talk about what we get when we're done. Okay, so once I've kind of grinded out this algebra here, plugging in 5 and 6, I get my 2 y values, so 5, 3, and 6, 9. And I know since the quadratics are symmetrical, then when I go 1 to the left and 2 to the left, I'm going to get 3 and 9 also. And so we see here that we have this stretched out quadratic, which again, the a value here is 2, so it makes sense that it's a little bit stretched out. And we have our 5 reference points, so we're good to go.